Hello everybody. In this video we're going to talk about dividing radical expressions. So let's write one down and just see what we can do with it. So let's start with this one. We're going to try to simplify this expression. So root 128 divided by root 72. Now there are a couple ways to do this. One way is to simplify the radicals in the numerator and the denominator separately and then go from there. So let's do it that way. This will be approach 1. All right, approach 1 will be to simplify root 128. So if you want to simplify a root, you try to find the perfect, well, in the case of a square root, find the largest perfect square factor. And in the case of this, it's 64. So I would write this as root 64 times 2. 64 times 2 is 128. Same thing for root 72. I would factor out a 36 because that's a perfect square. All right. And we know that the square root of a times b is the square root of a times the square root of b. So this is the square root of 64 times the square root of 2 divided by the square root of 36 times the square root of 2. The root 2's cancel, and we can simplify root 64 is 8. Root 36 is 6, and that simplifies as well. We can divide the numerator and denominator. What's the largest number we can divide these by? 2. Divide them by 2, you get 4 over 3. So that's the final answer. That's approach 1. Let me show you approach 2. A different approach to solving this problem would be to use a special property. That is the following. So if I have the nth root of a divided by the nth root of b, that's the same thing as the nth root of a over b. These are the same. Okay, so we're going to use that property in this one. So if I have the square root of 128 over the square root of 72, I can write that as just square root of 128 over 72. And now I can simplify this fraction in here before I do anything else. So 128 and 72 are both divisible by 8. If you divide 128 by 8, you get 16. If you divide 72 by 8, you get 9. So 128 over 72 simplifies to 16 over 9. And what can we do now? Well, now we can use this property in reverse, right? So now we're going to unfold it and look at it like root 16 over root 9. Square root of 16 is 4, square root of 9 is 3. And so we get the same answer. So two different approaches. You can envelop it into a single square root, simplify, and then pull the square roots apart, or you can just simplify the square roots individually. Keep in mind, though, one very important thing, these indices need to be the same. All right? If these aren't the same, then this property doesn't work. I mean, if these are different, then what do you put here? It doesn't even make sense. You know, if this is 3 and this is 2, which one do I put here, a 3 or a 2? It doesn't make sense. They need to be the same number so that you can put that number over here. And in this case, they were both, these are both square roots. The index is 2 here. Okay? So let's do another problem. Let's do let's try to simplify the cubed root of 24x to the 7 divided by the cubed root of 81x to the 4th. Okay, let me do it the second way. I'm going to write this as just one big cubed root of 24x to the 7 divided by 81x to the 4th. Okay? Let's simplify what's in here under the radical. Let's ignore the radical for just a second and just simplify what's in there. Well, they are both divisible by 3, so divide them both by 3. All right? 24 divided by 3 is 8. 81 divided by 3 is 27. And that's as simple as this gets. They don't share any other common factors other than 1. So that's as simple as that gets. What about the x's? Well, if you see the same variable in the numerator and denominator, you can simplify it by subtracting the exponents. So I'm going to take x to the 7 minus 4. 7 minus 4 is 3. And so there we have it. Let's see what else we can do with this. I think now it's time to pull this back apart. Right? So write this as the cubed root of 8x cubed divided by the cubed root of 27. And I can do a little bit more here. I can write this as the cubed root of 8 times the cubed root of x cubed divided by the cubed root of 27. So we're pulling this product apart. And the cubed root of 8 is what? It's 2. The cubed root of x cubed is x, and the cubed root of 27 is 3. And so there we have it. We're done. So let's look at this one. The square root of 320 mn to the negative 5 divided by the square root of 45 m to the minus 7 n cubed. Okay, so let's see here. Let's pull this together. Right, it is one big square root, so we got 320 mn to the minus 5. Right? So let's simplify this. Well, 320 and 45. These are both divisible by 5. If I divide 320 by 5, I get 64. If I divide 45 by 5, I get 9. Okay? What about the variables? Well, same thing that we did up here, right? If you have a variable, the same variable in the numerator and denominator, you can just subtract the exponents. So if I want to leave m in the numerator, I'd subtract 1, this is an exponent of 1, if you don't see it, it's always a 1, minus negative 7. 1 minus negative 7 is 8. If I did it in the denominator, I'd do negative 7 minus 1. I'd get m to the negative 8 down here. But I don't want that. I don't want negative exponents. So we want it in the numerator. We're going to subtract 1 minus negative 7. For the n, I want positive exponents in the end. So I better leave it in the denominator. I'm going to take 3 minus negative 5. 3 minus negative 5 is also 8. Okay? So now we can split this apart. We can write it as square root of 64 m to the 8 divided by the square root of 9 n to the 8. And we can pull this apart some more. We can write this as root 64 root m to the 8 root 9 root n to the 8. And square root of 64 is 8. Square root of 9 is 3. What's the square root of m to the 8? Well, m to the 8 is m to the 4th squared. So it's m to the 4th. And n to the 8 is n to the 4th squared. So the square root of something squared is just that something. So we get this. And that's the final answer.